Okay, so it's the A2, our first A2 homework. How exciting. And it's some chain rule and that kind of thing. So, firstly we had 6 questions just to ask you to find dy over dx. We begin with, I haven't aligned the board. Is it all right? Oh, no. Right, quick. Keep it rolling, it's okay. We'll soon get through it. Look how fast that was. Right, so we start with y equals 8x plus 11 to the 5. Now, shall we do this first one with the whole substitution-y thing, just to make sure that we've recapped how we do that? So what's the inside? Did we even do it with this? Do we need to? Can we just remember the rule for this one? How did you do it? Just the rule, which is ax plus b to the n is a times n, a times n times ax plus b to the n minus 1. And so we should have just written 40 8x plus 11 to the 4. I think this feels a little bit unfair by the time we get to the end of this, but I think we allocated 2 marks for each of these. So give yourselves a generous 2 marks if you got that right. Part 2. Well, this is still that same rule, isn't it? Because it's still ax plus b to the n. So when we differentiate ax plus b to the n, we get a times n, so 3 times minus 1, because this time it's the a is the coefficient of x, isn't it, in there, times ax plus b to the n minus 1. Oh, what's minus 1 take away 1? Minus 2, great maths there, well done. So that is, what should we write? Minus 3 over 1 plus 3x squared, although if you've left it as minus 3, 1 plus 3x to minus 2, I am still ecstatically happy. Right, part 3. Now this one, we are going to do, we'll do this with the substitution, just to remind ourselves how we did that, which is, we need to think of this first as being, it's the square root of 5x squared plus 3, but we need to think of it as being 5x squared plus 3, or to the power of what? Half. Good. So, when we think of differentiating this, we're thinking, what's the thing that you put x into first? So what we're going to make t in this case? 5x squared plus 3. In which case, y is t to the half. So dt by dx. What's dt by dx? So 10x is 10x, isn't it? And dy by dt is a half t to the minus a half. Now if we put this together, remember by the chain rule, dy by dx is the product of these two things. That's 10x times a half t to the minus a half, but of course we don't want to give our answer in terms of t, we want to give it in terms of x. So this is, well, half times the 10 is 5x, and then it is t to the minus a half. And again, Dave is happy with that answer, or that answer there, either are just as great. 4. 5e to the 4x. So this took us on to what we did later on in the week. And actually we can do this straight away. If you want to do the whole substitution thing, your t would be the 4x, wouldn't it? But we can probably just do this in one go. What did you get? Sorry?
20 to 4x.
Very good. Okay, because the 4 would come down, we multiply by 4, so we get 20e to the 4x, 5 times 4 is 20. Great, we gave a generous number of marks for that as well. Part 5 was 3 ln 2x minus 5. Anybody like to tell me what they got for that one? Nobody wants to say anything. Go on, Harvey, what did you get?
6 over 2x minus 5.
Very good. So dy by dx would be, it's if natural log of something, you get 1 over the something, but we need to multiply by the 2, that's the coefficient of x, and the 3 that was already there. 2 3s are 6. Brilliant. And the last one in this little set was natural log of 4x squared. Okay. Dave feels that he wants to show you this in 2 different ways. It's exciting, isn't it? So, the first way, well, how did people do it? With a substitution. So what did you use as your substitution, Ben? 2 is 4x squared. So y is ln(t), isn't it? So dt by dx is 8x, and y is, what do we get if we differentiate ln(t)? 1 over t. So dy by dx is the product of these two things, 8x times 1 over t, which is 8x over 4x squared. But we're not going to leave our answer like that. Oh no. We're going to cancel it down. X cancels, 8 divided by 4 is 2, we're going to write 2 over x. Did we get 2 over x? So some of us, lots of us did, some didn't. Right, I did say I wanted to show you an alternative to that. Look at this. You will love this. This is going to be really exciting. Natural log of 4x squared is exactly the same as natural log of 2x when you square it. True? Because when you square 2x you get 4x squared. Our laws of logarithms mean that that is the same as 2 ln 2x. So the original question was differentiate 2 ln 2x. They're the same thing, exactly equivalent functions. If you differentiate ln 2x, remember this was one that was a bit sneaky, we got slightly caught out with. If we differentiate ln 2x, we get 2 over 2x, or 1 over x. But we already had a 2 there, so it's 2 times 1 over x, which is 2 over x, which confirms what we did. How cool is that? It's 2 times 1 over x because it's 2 times ln. How do we get from there to there? If you square 2x, 2 times 2 is 4, x times x is x squared. So 4x squared is the same as 2x all squared. And then the logarithm clause, once that comes in. Great. Question 2. Oh, that's very small. Find the equation of the tangent to the curve y equals x squared plus 1 to the 4 at the point 116. Right. Equation of a tangent, that's a little code word that tells us that we need to do what? Differentiate. The question did say differentiation at the start of it. The whole exercise, topic, area thing. Right. So we need to differentiate it, just like what we've just been doing. Can I skip the bit of using t? And just say it is the big function is something to the power 4. And if we differentiate something to the power 4, we get 4 times the something cubed. That's how differentiation works. But now we need to multiply by the derivative of the inside function. The inside function is x squared plus 1, which differentiates to 2x. So we have 8x, x squared plus 1 cubed. Did we get that? For dy by dx. Maybe took more lines, but that's what we should end up with. At the point 116. So at 116, dy dy by dx is 8 times 1 times 1 squared plus 1 cubed. 64? I think. That's right, isn't it? 8 times 8 would give us 64. And we want the equation of the tangent at that point. So we do y minus y1 is mx minus x1. And we get, it didn't ask us for any particular form. Y is 64x. What's this going to be? Minus 64 plus 16, so minus 48. And there we go. We'll leave it like that. That's good enough as an answer. Are we ready for question 3? Find the gradient of the curve e to the x plus x squared at the point 0, 1. So again, find the gradient. So dy by dx. If we differentiate e to the x, we get e to the x. If we differentiate x squared, we get 2x. We're asked for the value of the gradient at the point 0, 1. So when x equals 0, dy by dx is e to the 0 plus 2 times 0. What did we get? 1. There we go, that was a simple 4 marks at the end, wasn't it? Great work. And that's maths. That was a